You probably heard the term negative emission technology. What does it mean? We will have, even after net zero, some emissions, greenhouse gases, CO2, etc., that have to be taken out so that we are actually removing more greenhouse gases than we are emitting. That's why we call them negative emissions. And typically we rely, or we hope to rely on bioenergy and other carbon capture sequestrations like direct air capture and enhanced weathering, etc., that we are discussing in detail elsewhere. The idea here in this paper is to use integrated assessment models to compute what investments are needed for these so-called negative emissions technologies, how much land and water and energy do they need. If you are doing BECCS, bioenergy and carbon capture and sequestration, then you have to grow the feedstock for that bioenergy. It could come from crops or other bioenergy vegetation, let's say, and you can also do it through afforestation or reforestation, etc. And when you do this, you also affect biophysical parameters like albedo. If you increase albedo, you will favor cooling because you are reflecting more of the sunlight. If you reduce albedo, you are going to trap more of the solar radiation. So you may compensate for the negative emissions with increased warming because of albedo changes and so on. So the integrated assessment models are not perfect by any means, but they are very useful for these kind of what if scenario calculations. And the paper does with two integrated assessment models some calculations for each of these methods, calculations on land needs, water needs, energy needs, investment needs, to figure out whether there are economic and biophysical limitations to actually accomplishing net negative emissions over the globe as a whole. For example, we imagine we're going to grow bioenergy crops on degraded land. Will that really work? How much of degraded land or regular land will you need? Of course, they will compete with food grains and water needs for industry, domestic agriculture, etc. as well. So it becomes very complicated very quickly, and there is never a silver bullet and there is never a free pass. So we have to keep all these things in mind when we keep on making future scenarios by saying we'll use bioenergy to get to net zero, etc. Okay.